So, good day everyone. So, for today's lecture, we will answer the set works that I gave you previously. Okay, so let's answer this set work. Express the given vector as Cartesian vector and determine its direction, angles, and unit vector. So, the first step is to find the points. So, we have 2 points here. So, this is point A and this is point B. Now, for point A, so we have to determine the distance of this point A along x, y, and z. So, let's start with A first. So, what is the distance of this point from the origin along x? So, this is the dimension and that distance is, okay, so that distance is 2 meters. And it's positive because it's going to positive x. While for y-axis, so this is the y-axis, so what will be the distance of that point from origin along y? So there is no distance of that since it's aligned to the origin, so that is 0 meters. And lastly, what will be the distance of this point along z? So this is that distance and that is 2 meters and it's positive because it's going to positive z, so that is 2 meters. While for point B, what will be the distance of this point along x? So this is the origin and this is the distance of point B along x and that is 4 meters. 4 meters and it's positive since it's going to positive x. While for y, so that is this distance. So what will be the distance of that along y? So that is 3 meters. And for z, so let's assume this is the origin because it's aligned to the origin. So what will be the distance of that? So that is 4 meters. Since this distance is below the origin, so that is negative z, so that is negative 4 meters. Now, after getting the points, we will now determine the position vector. So RAB is equal to, so that is Rx I hat plus Ry j hat plus rz k hat. Now, to get Rx, it's just xb minus xa. So that is 4 minus 2, so that is 2 I hat. Then 3 minus 0, so that is positive 3 j hat. And negative 4 minus 2, so that is negative 6 k hat, and that is meters. And to get the magnitude of that position vector, so that will be square root of rx squared plus ry squared plus rz squared. So that will be 2 squared plus 3 squared plus 6 squared, square root of that, so that will be 7 meters. And the next step will be the unit vector. So as I said, from position vector, we will extract the unit vector because the unit vector has the same direction force vector. So for the unit vector, we will use the formula of Rx I hat over R, which is the magnitude, plus Ry over R j hat plus rz over r k hat. So this is with direction, and in that case it will be 2 over 7 I hat plus 3 over 7 j hat minus 6 over 7 k hat. Since we already have the unit vector, we can now solve for our force vector, in which that is force is just equal to magnitude multiply it to its unit vector. The given 630 Newton, that is 2 over 7 I hat plus 3 over 7 j hat minus 6 over 7 k hat. And that will be 630 times 2 over 7, that is 180 I hat, plus 630 times 3 over 7, that is 270 j hat, and 630 times negative 6 over 7, so that is negative 540 k hat. And this is now your force vector, which is in a Cartesian vector form. Since we are also asked to find its directional angle, so we will find its alpha, beta, and gamma. But usually, we see that as all angles coming from its positive axis. To see it better, I will move this vector. So I will draw a vector which is a line here to our force vector, and I will move this into this position, so our vector starts from the origin. Okay, so this is now our force vector, which is this. And so for the alpha, that is the angle from positive x going to our vector, so that is alpha. For the beta, so that is from positive y going to our vector. And for gamma, that is from positive z going to our vector. So we learned that previously, that if the vector is on negative axis, so we expect the angle should be higher than 90 degrees. So let's solve first for alpha. So we will use the formula of cosine. Alpha is equal to fx over f. So that is the component of a force along x divided by its magnitude. So alpha is arc cosine 180, so that is Newton, divided by 630 Newton. Cancel. So alpha now is 73.40 degrees. For beta, so that will be arc cosine fy over f, and that will be arc cosine 270 over 630, so that will be 64.62 degrees. While for gamma, so we expect this will be higher 9, so that is arc cosine fz over f, and that will be arc cosine negative 540 divided by 630, and gamma is 31.00 degrees. Okay, so for number 2, express the given vector as Cartesian vector and determine its direction, angles, and its unit vector. So from this figure, so we have to find first its position points. So this is point A and this is point B. Now, let's get point B first because this is much easier compared to point A, since in point A, there are given angles. Now, for point B, so this is point B. Let's determine the distance of point B along X. So this one, so that is 5 feet. And that is positive because that is going to positive X. Now, on Y, so this is the Y-axis. So this is the dimension of point B along Y, and that is 7 feet. So that is 7 feet. And that is negative since it's going to negative Y. So let's write negative. And the dimension of point B, since along Z, since this point is aligned to the origin, so therefore that is 0. So for point B, that is 5, negative 7, and 0 feet. Now, for point A, so to get point A, you will imagine there is a vector here that is coming from the origin going to our point A, and we call that as your RA. Okay, so that a single position vector from the origin going to point A. And since that is a vector, we will get its components along x-axis, so we will call this as Rx, so that is the component of this vector RA along X. This is RY, since that is along Y, so this is the component of R along Y. And if we will align this one, so if we will get the dot, the component of this is the RZ, which is the same plan here. Okay, so let's solve Rx, Ry, and Rz, which is the same what we did to our previous lesson. So that is, first, I have to draw this lighter triangle. So this is RA and it has a magnitude of 10 feet. So I will just write 10 feet. Now, the opposite of 70 degrees, so this is 70, and since this distance is also the same with the same distance with RZ, so I will call this as RZ2. So this is RZ. And we need also this adjacent of 70 degrees because we will use this to solve Rx and Ry later, and we will call this the adjacent of 70 degrees as Rxy. To solve Rz, so since that is opposite, we will use sine. So that is sine 70 degrees Rz over 10 feet. So that is Rz is equal to 10 feet sine 70 degrees. Rz is equal to 9.3969 feet. We will get 4 decimals since this is not yet the final answer. And for Rxy, that will be, since Rxy is the adjacent of 70 degrees, so we will have 10 feet cosine 70 degrees. And the answer of that is 3.4202 feet. Okay, so we have Rz now and Rxy. Let's proceed to the darker triangle, which is this. And the angle here is 30 degrees, which is this one. Okay, so here is Ry and its opposite is Rx. And the hypotenuse is the Rxy. So to find Rx, it's just Rx is the opposite, so that will be Rxy sine 30 degrees. And that will be Rxy is this one, so that is 3.4202 feet sine 30 degrees. So that will be Rx is equal to 1.7101 feet. And for Ry is equal to, so Ry is the adjacent of 30 degrees, so that is Rxy cosine 30 degrees. And that will be 3.4202 feet cosine 30 degrees. So that will be equal to 2.9620 feet. So that is for Rx, Ry, and Rz. So let's write now the point A here. So point A has a dimension of, for Rx first, so that is 1.7101, and we will look if it's positive or negative. So since Rx is going to negative x, so this will be negative. While for y, so that is 2.9620, and let's check if it's positive or negative. Since it's going to positive y, so this is positive. And for Rz, so that is 9.3969, and that is feet. So that is positive since it's going up to positive z. We know now the position points. Let's determine now its position vector. The position vector RAB, so that is 5 minus negative 1.7101, so that is 6.7101 I hat. Then negative 7 minus 2.9620, so that is negative 9.9620 j hat. And 0 minus 9.3969, so that is negative 9.3969 k hat. And that is, the unit of that is feet. Now for its magnitude, so that is the square root of 6.71.01 squared plus 9.9620 squared plus 9.3969 squared. So the answer of that is 15.2502 feet. That is now for the magnitude. Now for the unit vector, so we will get 4 decimal for the unit vector since this is not yet the final answer. So that is 6.7101 divided by 15.2501. So that is 0.44 I hat minus 9.9620 divided by 15.2502. So that is 0.6532 J hat minus 9.3969 divided by 15.2502. So that is 0.6162 K hat. And since we already extracted the unit vector, we can now proceed for the force vector, in which that is the magnitude times its unit vector. So the magnitude of our force is 135 pound times its unit vector, so that is 0.44 I hat minus 0.6532 J hat minus 0.6162 Ka hat. And the final answer for our force is equal to, we will have 2 decimal only here, so that will be 135 pound times 0.44, so that is 59.40 I hat minus 135 times 0.6532 J hat, so that will be negative 88.18 J hat. Negative 0.6162, and that is 83.19 K hat, and the unit of that is pound. Now this is now your force vector into a Cartesian form. Now we are also going to determine the direction angle of our force. So let's try to draw this vector. So that is F. So this is our force vector. So let's try to move it. Start from the origin and going to its direction. So this vector is on positive x, negative y, and negative z, which is correct based on our answer. So from here, we will get its direction angles. So for the direction angle, so this is positive x, so this is alpha. This is positive y, so this is beta. And this is positive z, so this is gamma. So we expect that the answer for beta and gamma are more than 90 degrees. So let's try to solve alpha first. So that is cosine alpha is equal to fx divided by its magnitude. So alpha is our cosine fx, which is 59.40 divided by 135. So the pound will be cancelled out. So alpha is equal to 63.90 degrees. For the beta, so that is cosine beta fy over magnitude. So beta is our cosine negative 88.18 pound divided by 135 pound. So beta is 130.78 degrees. While for gamma, so that is cosine gamma fz over the magnitude of that. So gamma is equal to our cosine negative 83.19 divided by 135 pound. So gamma is equal to 128.04 degrees. Now this is now the answer for number 2. So let's answer number 2 first. So express each force into Cartesian vector form and then determine the resultant vector. Also find the magnitude, unit vector, and direction angles of the resultant vector. So for us to determine the resultant vector, there should be 2 or more given force vectors. So in this case, we have force AC and the force AB. So the force AB start at point A and ends at point B, while force AC starts at point A and ends at point C. So let's determine first the points A, B, and C. For point A, so let's determine the dimension of point A along X. So in this case, since there is no forward or backward distance of this point along X, that is 0. Now, we will also get the dimension of that along Y. So this is Y-axis, and that is 0.75. That is 0.75 meters, and that will be negative because this dimension is going or can be found on the negative Y. And for Z, so we will get the dimension of that along Z. So this distance is 3 meters, and it's positive because it's along positive Z. That is now our point A. For point B, we will determine the dimension of this. So this is what we called the X of B. So that is Rx. This one is along Y, so that is just the same here, so that is Ry, and we have no Z component because this point has no distance going up or going down from the origin. So we will just only get Rx and Ry. Now to get Rx and Ry, so I have to draw first. So I will draw the triangle first so that we can see it better. So this one is 40 degrees. This is Rx. This is Ry. And this is 2 meters. Now to get Rx, it will be adjacent, so that is 2 meters cosine 40 degrees. That is equal to 1.5321 meters. For Ry, that will be 2 meters sine 40 degrees because our Ry is opposite of 40 degrees. So that is 1.2856 meters. So our point B now has a component of 1.5321 meters. And let's determine if it's positive or negative. So this dimension is along positive X, so that is positive. Then for Y, that is 1.2856. And let's determine if it's positive Y. So this is just the same here. So that is from the origin going to positive Y. So that's still positive, and 0 component for Z. So we have now our point B. Now for point C, which is this, so we have the dimension along X. So that is 2 meters. So that is 2 meters, and let's check if it's positive since it's along positive X, so that is positive. For Y, so this is Y-axis, and we will get its dimension of this, which is 1 meter, and that should be negative 1 because it's along negative Y. And same, it has no dimension along Z, so that is 0 on Z. Okay, so we have now our points. So let's determine first the force vector of force AB. To determine the force AB, we will get the position vector AB first. So that will be, so that is B minus A. So that is 1.5321 minus 0. So that is 1.5321 I hat. Next is 1.2856 minus negative 0.75. So that will be positive 2.0356 J hat. And next 0 minus 3. So that is negative 3 K hat. And that is meters. Then the magnitude of that is equal to 3.9359 meters. So after getting the magnitude RAB, we will go directly to the force AB. Since we are not asked to find the unit vector individually, to find the unit vector alone, so we will proceed to force AB, in which that is the magnitude times its unit vector. And the magnitude of force AB is 250 Newton times, So to get the unit vector, that is 1.5321 I hat plus 2.0356 j hat minus 3 k hat divided by 3.9359 and cancel the meters, so that will be the formula. So the force AB now is equal to 250 times 1.5321 divided by 3.9359. The answer will be 96.6012 I hat. And for the second one, so that is 250 times 2.0356 j hat divided by 3.9359. That will be positive 129.3068 j hat. And lastly, 250 times negative 3 divided by 3.9359. That is negative 190.5681 k hat. And do not forget the unit, which is Newton. That is now for AB, force AB. Now, let's proceed for force AC. Now, before we can proceed for force AC, let's determine its position vector AC. That is C minus A. So, that is 2 minus 0. So, that is 2I hat. Negative 1 minus negative 0.75. So, that is negative 0.25 J hat. 0 minus positive 3, so that is negative 3 k hat, and this is meters. And we will get also its magnitude AC, so that is square root of 2 squared plus 0.025 squared plus 3 squared is equal to square root of 209 over 4, or roughly 3.6142 meters. So to find force AC, so again, we will just multiply the magnitude to its unit vector. So the magnitude of this is 400 Newton times its unit vector. So that is 2I minus 0.25J minus 3K divided by, so that is square root of 209 over 4. So that will be, okay, so this is force AC. Now, 400 times 2 over square root of 209 over 4. So this is equal to 221.3486 I hat minus 400 times negative 0.25 divided by square root 209 over 4. So that will be negative 27.6686 J hat. And lastly, 400 times 3 over square root of 209 over 4. That is negative 332.02 K hat. And that will be Newton. So, we now have force AB and force AC. We will now get its resultant vector. The formula for getting the resultant vector is just the sum of the given vectors. So, we only have two given vectors, so we will just add the two. So, that is force AB plus force AC. Now, remember, we can only add if the two directions are the same. So, we can only add I to I, J to J, and K to K. So, if we will now add 96.6182 I hat plus 221.3486 I hat is equal to 317.97 I hat. Then, 129.368 J plus negative 27.6686 J hat. So the answer is positive 101.64 J hat. So we will only have two decimals because this is the final answer. And that will be negative 190.5681 K hat plus negative 332.02 K hat. So the answer will be negative 522.59 k hat, and the unit of that is Newton. Now, if we will try to draw this one into our diagram, so let's assume this is, let's try to draw it first coming from origin before we put it here. So this is our R, and we have here positive X, so that is positive I hat, positive J, and negative Z. So that will be positive X, positive Y, and negative Z. So we can draw properly the resultant vector if we will scale this. Okay, so for assumption, okay, so we will have, so that is X, so this is a little bit of Y, and that is very long to Z. So this is now the position. Okay, so let's assume this is R, and we will put it here. So this is now your R, and since that is longer, okay, so this is now the position of your resultant vector R. Now from here, we are also asked to get the magnitude. So to get the magnitude of R, so that will be square root of R x squared plus R y squared plus R z squared. So the answer will be 620.11. So we are also asked to get the unit vector of R. So that is 317.97 divided by 620.11. So that is 0.51 I hat. Then 101.64 J hat divided by 620.11. So that is positive 0.16 J hat. And for K, that is negative 522.59 divided by 620.11. And that is negative 0.84 K hat. And lastly, for the directional angle, so that is for alpha, so that will be R cosine Rx over the magnitude. So that will be R cosine Rx is 317.97 divided by 620.11. So alpha is equal to 59.15 degrees. While for beta, that is R cosine Ry over the magnitude of R. So that is R cosine 101.64 divided by 620.11. Beta now is equal to 80.57 degrees. And lastly, for the gamma, so that is R cosine Rz over R. So that will be R cosine negative 522.59 divided by 620.11. And the gamma is equal to 147.43 degrees. Now, this is now the answer for this problem number 2.